Stan Gibilisco here, proprietor of ham radio station W1GV, Whiskey 1 Golf Victor, with a little more discussion about a hack that I did to an uninterruptible power supply. Uninterruptible power supply, also known as a UPS, not to be confused with the carrier of parcels. An uninterruptible power supply basically is something intended to allow you time to shut off a computer workstation when the utility power fails. This block diagram that appears here is figure 4-18 from Electronics Demystified, 2nd edition, published by McGraw-Hill. It is one of my books, and I briefly discuss how an uninterruptible power supply works. The 117 volt utility electricity goes into this device. There's a transformer, a rectifier, a filter, a battery charger, and a battery. And that battery is kept charged all the time, even when this uninterruptible power supply is switched off, as long as there is some utility voltage available. So normally what happens in this device when utility power is available is we have a transient suppressor or regulator, a surge suppressor, sometimes called a surge protector. I always thought that was kind of funny. Really, are you going to protect the surges in your electrical line from what? You? I think it's more like you want to protect your equipment from the surges. So it is and then they're not really surges anyway, they're transients, transient spikes on the voltage that can occur for various reasons. So normally the household utility electricity flows through that suppressor. The switch connects it right to your equipment. You can use a UPS with a ham radio station too, but you need to be prepared to switch your radio off and connect it to something like an emergency generator, because these uninterruptible power supplies are not meant to provide backup power for very long. That battery is a small battery. It's heavy though. If you've ever replaced one, you know that they're anywhere from the size of maybe a small brick, a very small brick, to a rather small brick. They're maybe as big as a lantern battery, 6-volt lantern battery in some cases, but they're very heavy, and they are lead-acid batteries generally, like the kind that you find in a motor vehicle. They're not intended to provide a lot of power, nor are they intended to provide power for any great length of time. So it occurred to me after my battery died in my uninterruptible power supply, which provides 1,000 volt amperes. That's how they're usually rated. 1,000 volt amperes is something less than that many watts. I'm not sure exactly why, but it will supply enough power anyway to keep me on the air with my little 10-watt radio and computers and things like that for 5, maybe 6, 7 minutes, giving me time to connect the backup generator. It's important to have some sort of backup power if you want to stay on the air during an emergency, a power outage that occurs during emergencies. But if you want to be on the air for any great length of time, you can't really do it with one of these uninterruptible power supplies, because this battery just won't last that long. So it occurred to me, well, that battery has died in this thing now, and I don't have any function in this uninterruptible power supply anymore, and it's a hassle and a pain in the neck to try and order one. And besides, I thought it would be kind of cool to see what would happen if I could connect automotive batteries in their place. So I checked to be sure that I knew what the battery voltage here actually was in this UPS, and it turned out to be something on the order of 26.5 volts. So I was going to need 2 automotive batteries connected in series in order to obtain the necessary voltage or anything like it. Now, a typical automotive battery, when it's fresh and not placed under a heavy load, will supply about 12.6 volts. So I'd get 25.2 volts if I connected 2 of them in series. So I went down to my local handy-dandy automotive shop down the highway on the way to Deadwood, and I got a couple of small automotive lead-acid batteries, and I wired the hack in a manner very similar to an article described in September QST on page 32. I wired that battery into the uninterruptible power supply. Now, when you do that, there are a number of precautions you need to take. The article did not specify what type of battery was used. I don't know. In retrospect, rather than automotive batteries, I would have been better off to use marine batteries or some other form of deep cycle battery. Deep cycle meaning that it's intended to be discharged quite a ways down many, many times, so you can use it over and over. It supplies a moderate amount of power for a moderate amount of current for a long period of time over and over. Automotive batteries really aren't designed for that. They're designed to crank your engine when you start your vehicle. They can provide upwards of 700 amps in order to accomplish that. A deep cycle battery won't provide that many amps, but it'll provide current for a longer period of time, and that you can charge and discharge it more times before it wears out. So that's the kind of battery to use. You need to be sure that you get the correct voltage, so you need to test the voltage. Because if you connect only one 12-volt battery into a UPS like mine that needs a little over twice that much voltage, you're going to have a problem. So you got to connect the right voltage. Now, another problem that can occur with these batteries is hydrogen outgassing. Lead-acid batteries can outgas hydrogen, and that can really be a danger, because if it accumulates near the battery and you get a spark, like can often occur at the terminals of a battery like this, deep cycle or otherwise, that can provide significant current, you know what's going to happen. You've got hydrogen hanging around there and you've got a spark. You're probably going to get a little explosion, and it could be a rude surprise. It might even cause you to be burned, and in the worst case scenario, it could start a fire and your house could burn down. Heaven forbid. There's another problem too, and that is acid leakage. Some of these batteries will eventually leak acid. You've got to take precautions such as setting your batteries in glass trays with baking soda in them so that you don't wreck your floors or carpet, whatever it is you put the battery down on. And of course, the acid can burn you pretty severely. I have had that happen. Sulfuric acid solution can be pretty rude when you get it touch with your skin. So you don't want that to happen. You need to be aware that these two phenomena can occur and that they can present a hazard not only to yourself but to your property. That said, the author did not specify what type of battery specifically was used, but there are a couple of questions when you do this with an uninterruptible power supply, when you remove its battery and place it with a different, larger battery. The first thing is, will the recharger that keeps this battery charged, this thing right here, this is designed for a battery that's the size of the one that was originally supplied by the manufacturer of the uninterruptible power supply. Well, will this battery charger function properly with a much larger battery? And the answer is I don't know. And if you have an answer, if you know the answer to that question from experience, I invite you to email me and tell me what your findings are. My email is linked from my website. By the way, once again, this diagram is figure 4-18 from that book, published by McGraw-Hill and written by me. I need to give them credit in order to use this illustration in any kind of publication. So there you be. My contract with McGraw-Hill is fulfilled, and maybe you'll buy that book. You can also buy other books of mine, which you will find links to from my website, sciencewriter.net. But if you know the answer to this question, will this battery charger right here be able to adequately keep a larger battery charged? Tell me if you know. Now, the other precaution that you need to be aware of is this inverter right down here. This inverter is designed to supply power to your equipment in the event of a power failure for a few minutes, maybe 20-30 minutes at the most, depending on the size of your computer, so that you can shut your computer down so that you don't end up messing up your operating system and doing a bunch of other things to your computer that you don't want to have happen. But will this power inverter right here be able to supply power for hours and hours and hours, either at a lesser amount than the maximum load of this supply or at the maximum load? If you have, suppose you got a huge series parallel combination of batteries with hundreds, thousands and thousands of watt hours, filled up a room with them. Well, would this, first of all, would the charger be able to deal with that? Would it adequately keep the batteries charged and properly keep them charged? And secondly, would this power inverter work for like 12 hours? I have heard that from some sources that is not the case, that in uninterruptible power supplies this power inverter can give out, might even overheat and catch on fire. I don't know about that, but if you know the answer to that question, because I don't, once again, please go to my website, sciencewriter.net. Go down to the bottom, you'll find a mailbox link down there, and then you have to type it in. I didn't want to put a direct link in there because it would cause me to get a whole bunch of spam. If you want to tell me I'm full of baloney, I guess you can do that too. You can tell me I'm full of baloney. But I'm telling you right now, I don't know. I can't give an incorrect answer if I say I don't know. So those are the two questions, the two big questions. What I do with this hack is I know that this battery right here is going to be capable of supplying all of the power that my entire ham radio shack needs for at least 10 minutes or so that it gives me plenty of time to connect up my backup generator, which happens to be a Honda EU 2000i. There's a little plug for Honda. They make really good generators, and this is, I think, one of their smallest ones, but it's enough to keep me in business for quite some time in the event of an emergency, a power failure. I guess out here in the Black Hills, the biggest danger is fire. That is the kind of an emergency that could cause the most havoc. Chances are in a fire, I'd just get the heck out of here. But another event that can cause big problems here is a snowstorm with a lot of wind, and we can get sometimes upwards of 5 feet of snow at a single pop. It's going to be hard for the crews to get to the power lines for a while. There was a storm out here once where power was out for 5 days, and of course, if you live in an area prone to hurricanes, you know already that you're probably going to want to have some kind of a backup generator. Or if you're into wind and solar, they do make solar-powered backups, but they are, generally speaking, don't have the capacity to keep you in business for a long time. It costs a lot more money to do that than it does to have a generator. So once again, go to sciencewriter.net and check everything out. Go to my YouTube channel too, my YouTube channel. I've got a whole bunch of playlists on that channel. I've got a ham radio playlist. I believe the title of it is Amateur Radio. How imaginative can you get? Once again, my call sign is W1GV. You will find me most often on 14 and 18 megahertz working CW and PSK, and not that often because I got a lot of other stuff that I do besides sit down in my nerd cave, believe it or not. So with that, I will say 73, Stan Gibilisco, signing off from the Black Hills of Dakota Territory, United States of America. See you later.